Hello guys, and welcome back to part two of this tutorial on this little code that we're writing here called Having a Ball. If you have not done part one, you will need to do that because we are going to pick up from where we left off. I will leave a link in the description to that particular part one, so you can just pick it up there. So what we had accomplished so far is we had our My World object. So we had created our world, our canvas. Inside there, we had written this little check-click method that was watching for when we clicked the mouse. And every time we clicked the mouse inside of the world, it created us a new ball object at that location. And then our ball object, we had got quite far into it. We started off very simply, where it was just black and a fixed size of 60. And we have now got to the point where there's a random size and random color. And what we're going to do now is we're going to continue on and finish this out. So the next thing we want to do is we want to give the ball a random heading, so its direction will be random. So whenever we create it, it'll be pointing in a different direction. So random heading, and a random speed. So that's easy enough to do. We're just going to say heading. Heading is one of the properties that we had defined earlier on here, so we can freely use it. So we're just going to say that heading is equal to. Then we're going to use this get random number. So I'm just going to copy that to save some typing. And we want to, obviously not a random number between 0 and 255, but we want to go between 0 and 359. Remember, the get random number method does not include the number you put in the brackets. So it's up to, but not including that. So it's from 0 to 359 will be what that method will throw us. So once we've thrown that random number, we are then going to use the set rotation method of the actor class to set our ball to be facing in that random direction. And then we're going to do the same with speed. Okay, so I'll just go and grab that again. Okay, so we want to give it a random speed. In the brackets, I'm just going to put 5. Okay, we don't want to leave it like that because obviously that would give us a random number from 0 to 4. And if it threw 0, then our ball would be stationary and it would stay like that forever. So we don't really want to do that. We want to make sure that we are guaranteed that the ball will be moving at least 1, at least a speed of 1. So that'll be 1 plus whatever random number we throw. Okay, and then we want to set the lifespan. We will get to this a little bit later on, but I'm just going to do it here quickly. We initialize the lifespan to be 255. Okay, so there's the extra randomization bits that we want to put in for the ball. Now what we want to do is, if we actually just put them on, the ball will just stay stationary because we're not actually moving it yet. It has the ability to move. Okay, we certainly can. It can move because we've given it a speed and a heading, but it won't move yet because we're not actually moving it. So I'm going to make a helper method here called move ball. Okay, and this method that we're defining here, this will be the one that actually moves the ball. So we're going to say private, okay, void. Once again, it doesn't return anything, it just does it. And we're going to say move ball. Right. So if inside here I say move, now move is once again, it's an inherited method of the actor. So I can just say move speed. Okay, and the ball will move. So let's do that. I'm going to compile. We're going to clean compile. I say run, and the balls are stationary. They're not moving. Why is that? Well, we saw this reason earlier on. It's simply because the fact that we have written this tool, this move ball, but we never actually call it. Okay, same as before. We've written a piece of code. It's there to be used, but we're not actually using it yet. And in order to use it, we are going to write an act method. Remember act? Act is the method that's like a forever loop in Greenfoot that'll run over and over and over 60 times a second. It must be called act, and we are going to use that to animate, to move the ball. So this is going to be it's a public method, so it's public. Once again, it's void, it doesn't return anything, and public void act. And inside of our act method, we say move ball. So there we call the piece of code that we wrote here, we call it from there. Let's compile that. What does it not like here? It says I've already got an act method. Oh, there indeed I do. Okay. So let me just go and delete that. We don't need that. I'm going to put my act method here. Compile. And here we go. Run. There we go. Now they move. And they are all going in random directions, and they are moving at random speeds. Okay, perfect. So now we can see we have a problem where they are hitting the edge of the screen. So now what we want to do is we want to make it so that when they hit the edge of the screen, we don't want them to bounce. We want them to teleport. So if it's moving in this direction, hits the edge of the screen, it must come flying in from the opposite side. I always think it's quite a cool effect, that. So let's have a look and see how we are going to do that. So we're going to do that here in the move ball section. Okay, it's all to do with ball movement. So now what we need to do is we need to check for when the ball is near the edge. Okay, and on here in Greenfoot and most programming languages, this is an X. Okay, so the horizontal is the X direction, the vertical is the Y direction, and the coordinate 0, 0 is in the top left corner. So that point up there is 0, 0, and it gets bigger going that way, and it gets bigger going that way, downwards in the Y direction. So let's have a look at this. We need to test. So we need to check if the ball is near an edge. Okay, is it near an edge of the screen? So let's see how we're going to do that. We're going to say if. Okay, and now in the actor class, we have this getX method. Okay, so we can get the X coordinate of the ball. Okay, so the X coordinate. So we're going to say if it's less than 2, we know that we are very, very close to the left-hand edge. Okay, because X is horizontal, 0 is on the left. So if the X position is less than 2, if it's 0 or 1, we know we are right up against the left-hand edge. And we'll do some coding in there to take it to handle that case. We can do else if. Okay, now we want to check, are we at the right-hand side? Okay, so are we near the right-hand edge? So once again, we're going to get the X value. And now we want to know, are we bigger than a certain number? Okay, so we know we made the screen 800 by 600. So we know it's 800 wide. So I could put here greater than 768 or say, 798 or 797, a number very close to 800. But the problem here is that would be a bad way to do it, because what happened if somebody changed the size of the world? and they didn't know that we had put this piece of code in here. So that's a bad way to do it. So we need to somehow get Greenfoot itself to check how wide the screen is. And luckily we can do that. Okay, so in the actor class, we have this getWorld method. So that will return us a handle on this world. Okay, so it points to that world. Now that I'm a world, I can run the getWidth method, okay, which is a world method. Okay, and that's going to tell me how wide the screen is. And I want to know when I am within 3 of the edge. So if the X position is bigger than the maximum width minus 3, I know I am near the right edge. Perfect. Okay, so that's 2 cases taken care of. Okay, now let's have a look. How do we know if we are near the top of the screen, the top edge, right? So this time we are going to say, right, we're going to look at the Y value, okay? Is the Y value, the Y coordinate, is it less than 2? If it is, if it's 0 or 1, I know that I must be very, very close to the top of the screen. So I'm going to say near the top, okay, because we're near the top of the screen. And then the last case we have to deal with is how to tell if we're near the bottom of the screen. So once again, we're going to look at the Y coordinate, and we're going to do very, very similar to what we did at the top there. This time we're going to say get world, okay, and then we're going to say get height. There's a get height method in the world that allows me to see if I'm very close to the extent, the bottom of the screen. So that there is near the bottom. So I have my 4 cases here. I'm either near the left edge, or I'm near the right edge, or I'm near the top, or I'm near the bottom. So now we need to deal with if any of those are true. So if I'm near the left edge, how are we going to do this? Well, we're going to use the set location method. Okay, this is the set location method. This is an inherited method in the actor class. Okay, set location, that will place your object at an exact position on the screen. So we can say to it, well, where do we want to go to? Well, we know we're on the left-hand edge, and we want to miraculously teleport to the right-hand edge. Okay, so it means I'm going to change the X coordinate. And what am I going to change it to? Well, once again, I need to find out how wide the screen is. Okay, so that will do it for me. Get the get width method of the world class. And then I'm going to just subtract 5 of the maximum. Okay, I don't want to put it too close to the edge. Otherwise, it's just going to bounce left, right, left, right, left, right, left, right. Because remember, this very next command is looking to see if it's within 3. Okay, so I make sure that I stay inside of this. So I'm going to say I want 5 pixels less than the maximum width. And I'm going to place it at exactly the same Y as what it was at. I'm not changing the Y. It's horizontal value. I'm not changing at all. I'm just changing its X value, the X coordinate. Okay, so what happens if we are at the right-hand edge? Same thing. We're going to go set location, and we need to tell it where to go. Well, in this case, we wanted to go to just 5. Okay, so it's 5 in from the edge, and whatever its Y value is. Now what happens if we're near the top of the screen? Okay, so same thing again. We're going to say let's set location. Where do we go to? Well, this time we need to have a look and see how deep, what is the maximum size of our screen. Okay, so that'll be get height. And we are going to subtract 5 from that, same as kind of what we did above. And get X, it's the Y that we are changing if we're near the top. So we leave the x what it is, and this time we are changing our vertical. Okay, so the x stays what it was, and we are changing the y value. And now if we are near the bottom, same thing again. This time we once again leave the x as it was, and we just place it at 5. Okay, we know that the top of the screen's at 0, and we just want to be 5 in from that. So let's compile that, and let's see what happens. Run it. Ah, look at that. They go out the side and teleport in the other side. And that's exactly what we want to happen. Okay, so it just pops out the one side and pops in the other side. Excellent. So we are well on track here. Okay, so what do we want to do next? Well, the next thing we want to do is we want to try and see if the balls hit each other. We want them to bounce off each other. Okay, so we want to bounce off other balls. So if they knock into each other, they kind of reflect off each other. So that's easy enough to do. We're gonna say if, and then we have this. There's kind of two ways to go about this, and we're just going to do it kind of the quick and nasty way. Okay, there is this is touching. There's an is touching method in the actor class. It's a little bit rough, but it works. Okay, and we need to give it a class to check. So we are saying to it, if you touch, okay, so if we are a ball and we touch any other ball class, so anything else that's in the ball class, so that is one way of saying all other balls, if we touch them, then this will say it's true, and then the piece of code inside the if statement will run. So if that is the case, we're then going to say heading is equal to heading minus 180. We're just going to subtract 180 degrees of whatever the heading is, and that immediately just makes it go the other way. And we say set rotation to heading. So we then set the direction of the object in that heading, and then if you run this, you'll see it'll work, but there's a small extra thing you want to do is that if they do hit, you just want them to immediately move away from each other right there and then. Okay, so they will tap each other, move away, and then the thing will loop around again. Okay, let's have a look and see how that works. Compile that. Let's run our code. And now if balls collide, they should bounce off each other. Okay, so that's looking good. They definitely look like they are bouncing off each other. And so we come to the last section, okay, because you can see here as I am making more of them, it just becomes more and more cluttered because they're living forever. They're not dying. And what we want them to do is we want them to slowly fade out and die. So let's go and do that last section. And the way we're going to do that is we are going to use we are going to decrement the lifespan. Okay, so remember the lifespan was this number that we set to 255 up top here. We set it to 255. And remember, move ball is running in the act method. So it's running 60 times a second. So every 1/60th of a second, this move ball executes. So what we are going to do is we are going to decrement that lifespan value of 255. We're going to say lifespan minus. That's the same as saying lifespan equals lifespan minus 1. So we're removing 1 from the value of lifespan. So lifespan will get smaller by 1 every 60th of a second. And we are using this lifespan as the transparency. Okay, so we know that our image is called IMG. Okay, you remember that from last time. When we created it, there it was there. That's the image. Its name was img, and we initially, in the constructor, set its transparency value to 255. And now we want to decrement it. So we're going to say image set transparency to be lifespan. So as lifespan counts down, the transparency will go to a lower and lower number, and the ball will become more and more invisible. If we leave it like this, we're going to have an issue because the transparency cannot be less than 0. And lifespan is going to just get smaller and smaller and smaller, and when it gets to 1, it'll become 0, then it'll go to -1, -2, -3 if we're not careful. So what we need to do is we need to say, right, if lifespan is less than 1, okay, so as soon as lifespan becomes 0, then I want to completely kill the ball. Okay, so it's invisible now, and I literally want to get rid of it out of the world altogether. So I say get world. Okay, like we did before, we know that then refers to the world in which the ball is living in. Okay, which in this case is my world. So we say get world, and remember in the my world we used the add object method. The opposite side of that is remove object. Okay, so this time we are going to remove an object. Okay, and which object do we want to move? Which object do we want to remove? Well, the object we want to remove is this. It's whichever ball has got to a lifespan of 0. Okay, and we didn't create each ball with a name. We just let the computer keep track of all of that. If we had 50 or 100 balls, each ball had a unique name in memory, because there are 100 unique different objects, but we didn't give them a name. So this keyword is a very handy way to refer to this particular object, this ball. Okay, so whichever ball has got to a lifespan of 0, that one will be the one that gets removed. So let's compile that. Let's go and run that. That should be we should be done now. And you should see they're slowly dying out. They're bouncing off each other. And everything is working exactly as we wanted. It might not be 100%. 100%. There might be little times here where the ball sticks together or something. We haven't catered for those sort of issues, but it's good enough for you to have seen how Greenfoot works, and I think we're all if you understand how this code that we've done over the last 2 lessons works, that is excellent. And what we'll do now from the lessons going forward is we'll actually we'll use the same techniques that we've learned here. Okay, so we've learned a lot about object-oriented coding and constructors and inheritance, and how to go and find the methods in the Greenfoot classes. And we're going to use these exact same techniques to build some games. So hopefully you had fun doing this one and you learned something. Please come back for the next lesson.